Hi, this is Dr. Carl Goldkamp. If you're interested in learning about the ketogenic diet like I was, to save my own life, then this is probably the podcast for you. 8 years ago, I knew nothing about it. 6 years ago, it saved my life. 3 years ago, I started researching and talking with some of the authorities in the field and attending medical conferences about this to understand why and how keto so dramatically changed my and my wife's Judy's lives. The purpose of this podcast is to share our journey of discoveries with you in understanding how keto is so effective in improving so many different conditions, from obesity, epilepsy, diabetes, infertility, MS, Alzheimer's, heart disease, to name a few. So take a step away from all the hype you've probably heard and roll up your sleeves with me and join me weekly to explore this living miracle that anyone can access. We'll talk science, we'll talk food. We'll explore its history and evolution to today, which is that the sheer wonder of the ketogenic way of eating has changed untold number of lives, unlike anything before it. And in case I forget to mention it, please join our Facebook group, Keto Naturopath. Hi, this is Dr. Carl Goldkamp, and welcome back to another episode of the Keto Naturopath. Today, I'd like to try something that I've sort of toyed with a little before. We're going to do bits and pieces of other audio clips put together as a theme from some people that are authorities in the field. Some you've heard my name, you heard me reference them before. So we're going to talk about ketones, of course. We're going to talk about the context of Alzheimer's and about the brain. So we're going to look at a lot of the issues that have to do with ketones, glucose, ketosis, glycolysis, ketolysis, and you'll get an idea of what the brain is about. I think that's pretty important because when we've been talking about things you can do to put off or to prevent against dementia and Alzheimer's and mild cognitive impairment. One of the people that I'd like you to listen to, and I've interviewed him a couple times, I interviewed him for a very long time over a number of podcasts, and that is Dr. Stephen Cunnane. Right now, you'll be listening to him talking at Ohio State. And let's hear what he has to say.
Used by the brain, there's two different strategies. I notice on my screen that it's partly cut off, but I'm glad to see it's not cut off at the top for you. So the two strategies are that the glucose gets into the brain because it's pulled into the brain. This little stick person is pulling a glucose molecule into the brain, which is on the right. And that process occurs through the glucose transporter, and it's driven by a fall in glucose in the brain cell that's doing some job, communicating with its neighbor. So this is a process that's driven by brain activity. That's strategy number one. It's still supplying most of the fuel that the brain is going to use. But the alternative strategy is driven by ketones, and it's a push strategy. So when the ketones go up in the blood on the left, they are pushed into the brain. And this is the way the brain works all the time. If glucose goes down because you've been fasting for 24 hours, for argument's sake, insulin is down and ketones are being produced, and they will go into the brain in relation to the concentration as shown on this slide. So this is a compilation of a number of studies, which I've compiled in the publication that's noted. And you'll see on the x-axis the plasma ketones are on a log scale. And the fasting indeed goes from the postprandial to 24 hours fasting, 40-day fasting, which was referred to George Cahill's classic work. But there is also a paper published in the Journal of Clinical Investigation on a 60-day fast in obese individuals as well, where you get over 10 millimolar beta-hydroxybutyrate in the blood, and you're supplying, as you can see on the y-axis on the right-hand side, about 85 to 90% of the brain's energy requirements.
Okay, so what did you just say? There's two mechanisms, two fuels for the brain. One is glucose, obviously, and the other is ketones. What is the difference? And here's what's pretty interesting, and I hope you pick this up because it's something you can use for the rest of your life in understanding your brain fog, if you will, understanding your mental fatigue, whatever you want to call it. You'll get a sense, or understanding your MCI or lack of MCI, mild cognitive impairment. So what that is that glucose needs to be triggered to be sucked in, if you will. So there's a mechanism, there's receptors that have to be activated. And so when that gets activated, usually by insulin, that's one of the cofactors and a number of other things, but it's an active of sucking it in from the bloodstream. Whereas ketones are kind of the door is always open to ketones. There's no activation. They climb per concentration in the bloodstream. So as you get a higher concentration in the bloodstream, you get more and more ketones. So what he referenced was a scale, pretty much an up, down, and sliced right in the middle diagonally from lower left to upper right, with all these different studies over the last, since the 60s, so that's over the last 60 years. Famous studies, actually. And so what he showed was the longer the fast, the higher was the percent in the blood of ketones, and he could measure, or per those studies, they measured how much ketones were being pulled into the brain, how much ketones were in the bloodstream. So how can you use this? Well, you have this gizmo called a ketometer, right? Ketone meter, ketometer. It's part of your Keto Mojo, if that's what you're using. The number is right there. So often people get a 0.5 to 1 to 2 to 3 to 4. I think the highest I've ever had is an 8. And so how did I get that? Well, basically it was putting our mayo together with C8, and it's fairly easy to do. So that's what he's talking about. There's two different fuels, but there's two different mechanisms to use those fuels. One is strictly by the concentration in the blood, obviously of the foods that you eat or the fasting you're doing, the other way of getting ketones. And so these two fuels, are there for a purpose.
Obviously, it's an extreme situation, a non-physiological situation, probably ethically impossible to do today. All I'm using it for is to demonstrate the principle that as ketones become available in the blood under these circumstances, they will be used by the brain. So there's a linear relationship over a 600-fold range at least, which is an extraordinarily efficient way of providing a backup fuel for the brain. The third point I want to make is that glucose is the main fuel of the brain under most circumstances, except under extreme fasting, but it's not the preferred fuel. So there's a difference between the main fuel and the preferred fuel. And this is an example of a study that we did with a PET scan. I'll show you how we did the PET in a minute, but I wanted to set the stage for the Alzheimer's studies with these couple of preliminary points. So on the x-axis, you can see a change in brain ketone uptake caused by the ketogenic diet. So these are delta values. They are increasing amounts of brain ketone uptake compared to the pre-ketogenic diet stage. And on the y-axis is the glucose uptake, which goes down in proportion to the increase in ketone supply. So glucose uptake is going down when there's sufficient ketones around to go into the brain. So this is an inverse relationship, and it's why I refer to ketones as being the preferred fuel. We're not the first people to have shown this, and there's a very useful glucose-sparing effect that, in fact, occurs on the ketogenic diet. So the context for this in relation to aging and Alzheimer's disease is shown by these two little arrows. And if you look at the two scans, you can see that the one where the arrows are has basically missing.
So we're looking at our two brain scans, basically, of a normal brain. So you see a lot of colors that show there's a lot of glucose uptake of your whole brain, pretty much symmetrically. And then we have an Alzheimer's brain in which we see, well, really half the brain doesn't have the same colors. And what that signals is there's far less glucose uptake. And so here's what the assumption is about that.
Of what one sees in Alzheimer's disease, and it's been known since the dawn of PET scans in the late 70s. The interpretation has almost always been, well, the brain cells are dying in Alzheimer's disease, so they don't need glucose, so the glucose uptake goes down. And that's a logical interpretation, except for 2 points that I want to make. The first point, and it's in this concept that we've developed over the past couple of years, along with some other people around the world, is that in fact the glucose problem is specific to glucose and it precedes the cognitive deficit in Alzheimer's disease. So how do we know that? What we're talking about is still the definition of the glucose deficit is defined by the PET scans where the reddish color is declining, and that's showing lower glucose uptake in the brain. In the yellow box, there are 5 categories of people with pre-symptomatic brain glucose hypometabolism. And they're all categories of individuals at risk of Alzheimer's disease. Who are they? Older people, people with insulin resistance independent of age, people with a family history of Alzheimer's disease, people with that are ApoE4 carriers, and the presenilin mutation. So those are very different groups of people. They've all been identified as having a risk of Alzheimer's disease, an elevated risk of Alzheimer's disease, and they all have pre-symptomatic brain glucose hypometabolism. So this cannot just be a consequence of the disease. They don't yet have the disease. They're all cognitively normal. They're at risk, but they are still cognitively normal when the PET scans have been done. I haven't given you the citations. I'll be happy to, if you look up our work, all this work has been referenced and has been done by other groups. So the way we look at this now is that this latent glucose hypometabolism is in fact helping precipitate the neuropathology associated with Alzheimer's disease, deterioration of synapses, and deterioration in brain function, which is associated with cognitive decline and which is going to push down the glucose metabolism further and is going to create a vicious cycle of brain energy exhaustion and progression of the disease.
So the concept is glucose hypometabolism. That simply means it's taking up less and less glucose. We don't know why, and put those categories at risk, but eventually you start seeing this on PET scan. So PET scan is the imaging that's used so you can see the glucose uptake. So the glucose speaks to the active parts of the brain. Okay, that's what a PET scan is. And so Dr. Cunnane is perhaps the first or second in the world to talk about ketones and their ketone uptake, and he's going to get to that. So the question comes, why is there a hypometabolism? Why is there less glucose being used? Actually, it's less glucose that can be used, because it turns out, and I'm sort of throwing in some of the answers far ahead of time, and that is this has come from a life in a culture that had high carbs. So your elevated glucose as a daily event was always there. So eventually, and that was too much glucose. And so your receptors in your brain, various parts of your brain, start to prevent, they block, they downregulate, they make fewer receptors, so less and less glucose can be taken in. So it's actually a protective mechanism from having too much glucose available. So you understand that? That's actually a big deal. So it's from the era, from the time of period in one's life of having consistently elevated glucose. Maybe you're not diabetic or not, but it's higher than what our genes have for the millennia been wired to or evolved to have. So it's just too high for too long, forces our brain mechanisms, our receptors for glucose to downregulate, to become fewer, which means we take in fewer. So once the glucose, there's less that we can take into our brain, and should there even be less glucose we're taking in, there's even less and less glucose. So what happens? Well, if there aren't any ketones available, these various cells start to die. And so that's what you're seeing in Alzheimer's, in dementia, in mild cognitive impairment, etc., is the death of the cells that aren't getting enough glucose. Pretty interesting, huh? Let's continue.
So we could argue about whether the neuropathology comes before the latent glucose hypometabolism, but we have a way of assessing this and saying, if there are two fuels that the brain can use, what about brain ketone uptake in people at risk with Alzheimer's disease or at risk of Alzheimer's disease? If it's the same pattern as it is with glucose, then we know the neuron's completely screwed up, or the astrocyte, because it's a different transporter mechanism, it's a different access point to the Krebs cycle, it's a different pathway until you get to the common pathway. So let's explore brain ketone uptake in these conditions. So how do you do that? You do what we've called dual tracer quantitative PET imaging, and the protocol is shown here. We do the PET image with a ketone tracer, which is acetoacetate, carbon 11 labeled, short half-life, so you have time to collect the...
So what we're about to talk about are two images of sets of of normal people, left and right side of the brain, mild cognitive impairment, right and left side of the brain, and Alzheimer's disease, right and left side of the brain, in terms of how much glucose is being taken up. And what we can see is a color change getting worse. So worse, less and less glucose is being taken up. And now we sort of see that as a rule. So next to that, let me just sort of plug in Dr. Cunnane again.
The capacity of the brain to use glucose decreases in Alzheimer's disease, and this has been established for many, many years. If we look at the ketone uptake in exactly the same individuals, you can see that the green color, in fact, the capacity is lower than it is for glucose under the normal circumstances, but it, if anything, actually increases as you get towards.
So what he said is the same people, the exact same people, so the exact same brains that we're looking at, it basically said as the brain is being starved of glucose, I'll use that reference, or has more and more difficulty in bringing in glucose to those nerve cells, so they begin to malfunction, be less active, die, however you want to reference that, from control to mild cognitively impaired to Alzheimer's disease, what you see is a slight increase to bringing up ketones, an increase. Remember I said there's no mechanism? So what they showed was more ketones are being brought into the brain. So something's changing a little bit there, maybe some sort of concentration gradient. So two brains is one effect of bringing in glucose is clearly affected, right? One fuel just cannot be used. For whatever reason, can't be used. The other, through all this change in the decades or the people and in the physiology and so on and so forth, yet ketones can still be used. Can still be used actually better than they were right after birth. That's pretty amazing. So what you have is a special fuel for Alzheimer's, MCI. So it's a big category. So that's why Stephen Cunnane also did the study I've talked about before. I can't remember if we talked about it on his interview, is that, and he has, we may or may not get into it in this particular section here, of MCT oil. And he does both C8 and C10 as one oil. So we'll call that, coconut oil, if you will. And then C8. And C8 obviously is far, far more efficient in providing those ketones. So therefore, and that from his work primarily, people then learned, well, maybe we can patent the ketones that are naturally occurring in MCT oil, C8 MCT oil specifically. And if we patent it, then we can recoup it, make money. So there are a number of people that have gone on and made patents of various exogenous ketones, things you can take in powders and drinks and so on and so forth. And I've mentioned that before. They're more convenient. There are certain powders, but they're very, very expensive. So it's really interesting that you have something so simple as MCT oil that can come in and actually provide that kind of benefit and bring it up to normal functioning.
You get towards Alzheimer's disease. There is no loss of the capacity to transport ketones into the brain. It's the same cells. So they can't be dead because this is an active transport-mediated process. So this is encouraging us to believe that we could use the normal brain ketone uptake capacity to, in fact, bypass the glucose deficit and potentially have an impact on cognitive function.
That's pretty impressive what he just said. So can you imagine this? I mean, this is like an open window. Let's say it started maybe, not even 10 years ago. Let's say 5 years ago. I saw him first speak in 2016. So that's now 4 years ago. So it's been very new. And to provide this kind of benefit for any of us, but especially for those in nursing homes and so on and so forth. Remember when we talked to Dr. Christopher Palmer and his father's experience? They got worse in the nursing home. Well, if they had nursing homes that provided this kind of ketogenic food, that's amazing what they would have. They would have people that would be much more preserved, active, enjoying life for those last 5, 10, 15, or 20 years, however long that they were there. So the question that is brought up by these two different fuels and some of what he cited before is that, okay, that's all fine or good. It sounds like you're saying that this is a remarkable opportunity for the brain to start using ketones as this additional fuel. in lieu of the fact it can't use glucose anymore because it damaged itself. So they actually did a trial over 6 months of using 2 tablespoons a day, 30 grams, a tablespoon of MCT oil. A tablespoon of any oil is 14 grams. So roughly 2 tablespoons per day of MCT oil. And what he found, and he referred to C8 was better than C10, C8. I don't think it would be big enough for him to make a big deal over it, but you could see that part of the graph. All right, so what does he have to say about it?
Normal in mild cognitive impairment. And the answer is yes, it's the same results as I just showed you for Alzheimer's disease. But we still have 19 or 20 people per group, and we had a placebo control on this, so we have cognitive results, and you can see that there are several domains of cognitive function that improve, particularly episodic memory, but also processing speed and language that do not improve on the placebo. So this is encouraging, but it's not definitive because a clinical effect with a cognitive outcome would require probably closer to 100 people per group.
Now we're going to look at another study strictly of mild cognitively impaired individuals from younger to older, and then we're going to do 3 subcategories of mild cognitive impairment. So what we have is mild cognitive impairment, placebo, they're not going to get any help. Then we have those who take 2 tablespoons a day of MCT oil. And then we have those who take it's 45 grams, and so that would be 3 tablespoons a day. And so what we have as a concept is that, let's say your brain needs X amount of fuel, right? Combination of glucose and ketones. It can be all ketones, it can be all glucose. And so we know over time that our ability to process ketones decline in this culture of the people we're dealing with. And so what he's noticed, and others have noticed as well, is that ability or that decline of using glucose starts in the 20s in many people. So the MCI starts a lot younger than we initially thought. And that's kind of disappointing for many of us. And if you had to study for college exams later on in life, now you know why it was harder for you than the younger people. It was your ability to use these fuels. But it's really interesting in these 3 categories of MCI that it's real straight, they're all the same limited amount of using glucose. Yet the difference to make sure they got into the gap of, call it viability, to have a cognizant brain, you needed to make up that energy gap. So you added 2 tablespoons a day. That brought it up into the low part of the gap. Then you added 3 tablespoons a day. That brought it up almost to normal. And I'm sure 4 by the outcome here would have been a normal brain of mild cognitively impaired person. That's very impressive. Let's see what he has to say about this. I know it's a little technical, but I think for you to know this and to hear this is a lot better than just thinking, I just think there's too much fraudulent information in this whole keto realm, and it's just nice to hear somebody, splicing away the facts.
So we look at this now in terms of the green band in the middle here. What is the energy rescue or the gap in energy supply to the brain that we're trying to fill? So let me take you through this. The bar on the left here is the young, healthy controls. And their energy supply is there in the normal group, so they're at 100%. And their brain energy is coming, as you can see in the table at the bottom, about 95% from glucose and about 5% from ketones, using the dual tracer ketone PET imaging. So that's the young healthy controls. Older healthy controls, we've got about 30 people in that group, and you can see that the total height of the bar is lower. The ketone contribution is a bit lower. It's not that the K value for the ability to take up the ketones goes down, but in fact, plasma ketones drift downwards as you get older. So their contribution to brain energy metabolism goes down. But it's glucose that is going down in principle here, mostly from 95% contribution to about 89%. But they're all cognitively normal still. Then you go to MCI, which is the middle bar, and the value has gone down a little further. So there's still a significant drop in glucose, although the ketone uptake is still the same as it was in the healthy older people. Then the second bar from the right is the trial I just mentioned, the Benefic trial, in which the MCI patients were on 30 grams a day of the MCT. And now we've helped restore them closer to the healthy elderly with the ketones, which are now contributing twice as much as they were in the healthy elderly, but the glucose contribution has not been changed by the MCT supplement. So this is suggesting to us that if we want to get a more complete reversal of the energy deficit, we're going to need to get into 45 grams a day, roughly speaking. And that was going to put us somewhere between the healthy elderly and the healthy young, which seems like a reasonable place to be. We might be able to get right up to this 100% value perhaps with a ketone ester or some other supplement. We're still exploring that. So this is telling us what our therapeutic target is. It's giving us a dose that we should be looking for in order to accomplish this particular goal. This is the same slide, but it's a little busier now because I've added the Alzheimer's group here. So from the MCI, we get a further decline to a value of a deficit of about 19% in early Alzheimer's disease. So a person with early diagnosis of Alzheimer's disease, day in, day out, is facing a 20% energy deficit in their brain, constantly. MCT is one way to help correct that, as we show you here, but you can see that the group next to the Alzheimer group here is an exercise group. And in fact, exercise helps get glucose more into the brain. It also helps get ketones into the brain without a ketogenic supplement at the same time. It's helping to increase the K value, the number of doors into the brain.
So let me go over what he just said. We talked about the MCI. I'm not going to go into that. The more MCT oil, the better. He now mentioned, well, we could actually bring it up to 100%, just like the young people were, by giving them maybe ketone esters and so on. We'll find out. And then the next graph was about Alzheimer's. And so we had 4, sections of Alzheimer's with MCT and without. The first thing you notice is they have far lower functioning ability to use glucose. So they have a bigger gap to make up. So they're far more deficit. So one, just exercise alone increased the ability to use glucose and increased the ability using ketones. He mentioned the ketone plasma level concentrations decrease with age. So that's a big deal. So exercise, and when he means exercise here, it's cardiovascular. So we go from there. And then you could see the ketone levels would come up with the MCT, but not as high as the mild cognitively impaired. So I'm going to stop here on this particular topic because he's gone into it and he's the guy who knows, and he verified that over age and condition, you have a decline in the brain's ability to use glucose. That changes only with exercise. And if you add ketones, that will make up for some of the energy deficit, maybe 100% if you're not impaired that much. So let's pause here. And just what I expect you to know, there's 2 fuels, the efficiency varies, and be aware of that. One point that I thought was very important to make, and I've chopped up some of his presentation, is that we haven't talked about the ketogenic diet. We just talked about the supplement, quote unquote, the supplement of the medium chain triglycerides, it's MCT oil, and how that alone and giving it to these impaired individuals helped, that with exercise. Now to that, and this is a chapter of his presentation, add the ketogenic diet and add the supplements, and you got an incredible return for your money. And he showed a set of brains pre-ketogenic diet using their ketone uptake, which was not at all. And those on the ketogenic diet, ketone uptake was very high. So don't think that you're taking a supplement in lieu of the ketogenic diet. Obviously, it's harder when you're working with Alzheimer's. It's the caregiver. I mean, it's a whole level of sophistication. Understood. This is getting a point across. And he had mentioned it is difficult to get this kind of research done because you're dealing with people that are maybe not completely aware of what they're doing, and they need this to be sort of implemented to them, for them, and with them in that regard. But interesting. So ketogenic diet and the MCT is a big boon. Whether you need the exogenous ketones or not, another question for another answer at another time. And it's stacked with big financiers, is my point. Maybe I'm too skeptical. And to add to the point that I just made, is if you see the amount of energy that is needed for the brain to operate, we'll call that 100%, right? So they measure the young versus the old. And so you're trying to make it up with the combination of fuels. But what is interesting with the ketogenic diet only, so now that's a big word because we don't know, did you start last week? Have you been doing it a couple of years? It's a big transition. But on a ketogenic diet, you can get up to 113% of utilization of total energy. That's glucose and ketones. So you have a more hyper-functioning brain on the ketogenic diet than a functioning brain on the regular carb, standard American diet, whatever you want to call it, the non-ketogenic diet. I find that's amazing when you think about, well, not just getting older and cerebral vitality, but you think, I would have loved to have this when I was in medical school and these other things. You're really focused, get these things down, stay there, and it's just very important. So 113% on the ketogenic diet is far better. And let's see what he has to say here on that particular point.
For reasons that I don't need to explain. They're both about 100, but in fact, you can get to 113% or so on a ketogenic diet. There's more energy getting into your brain on a ketogenic diet than there is on a typical Western diet. So there's not just a therapeutic effect, but potentially a cognitive benefit in those that are not facing aging-associated cognitive decline.
Isn't that amazing? Isn't that amazing? So think about that whole world of people trying to take supplements for their brain. It's called nootropics as a category. It's a made-up fake word, but it basically means things that helps nerves, particularly. And it was just a word out there. You take choline and a few other things. All fun things to talk about, by the way, in another podcast. But this alone, the ketogenic diet, is far measurably. I mean, there's research now showing this. There's no research on all these other little supplements in any large number, however they work or don't work. That's just incredible. So I'm over the moon on this one particular fact. I hope you are too, because it's something everybody can use. It pulled it away from any sort of pathology and said, this is something everybody can do, should do in terms of brain energy, useful brain energy. I want to finish up this particular thought that he's working on, and we're coming back to that image of a control versus Alzheimer's. And we see in the back part of the brain, behind the ear, so they call it the parietal area, they're darkened areas. They're not the bright red. They're impaired. They cannot bring up the glucose. And so here he's going to summarize what that's about and what he feels can be done. And I just think it's a wonderful thing to share, and it's straight from the horse's mouth. And it's a little on the technical side, but I'm hoping not too much. And I hope you enjoy this.
I just want to come back to this image and say that those arrows are definitely a consequence of the disease, but they're also contributing to the disease. They are present, the arrows are present before the disease starts, and it's a glucose-specific problem. That brain energy rescue by ketones is definitely feasible in mild cognitive impairment. It's feasible in Alzheimer's disease. What we're trying to do is basically let the brain have the luxury of thriving in a fuel environment that you were born into. And the fourth point is that the cognitive benefits still need to be better defined, as well as the mechanism of action. We don't know if it's, as alluded to earlier today, we don't know if it's just a fuel effect or whether there's some signaling effects, whether there's some anti-inflammatory effects, whether even affecting the pathology in the brain in this situation. So I want to finish by thanking a terrific...
Now I'm going to jump to another audio by two other people speaking, both interesting people, and I've seen only one of them speak personally, and the other learned of, but the conversation is very interesting. So this is from the podcast, A Diet Doctor, and he's talking to a professor, doctor, an academician from Brigham Young University, Ben Bikeman. And we're talking about, this is just adding on to Alzheimer's and what he now knows of Alzheimer's, and a little study that he's done, which I thought would be a really interesting thing to add. So you understand the process of Alzheimer's, dementia, MCI as a collective, and as a collective, and similar in the sense of their inability or worsening ability to use glucose and their unimpaired ability to use ketones. Let's see what Dr. Bikeman has to say.
Truly, and I mean it, what a tragedy, especially when we look at it in the context of diseases of Alzheimer's or overt or genuine instances of glucose hypometabolism, although this is a tangent, but when we know that in Alzheimer's disease, the brain cannot use glucose as well. We are just about to publish a paper looking at gene expressions from different sections of the brains, human brains postmortem, looking at glycolysis genes in brains of normal brains versus brains with dementia versus ketolysis, the ability of the brain to use ketones.
Really?
Whether the brain dementia or not, ketolysis gene expression perfectly normal. Glycolysis gene expression not at all.
Interesting.
And I'm talking about p-values of 10 to the negative 9. I mean, these are massively beyond any hint of coincidence.
Yeah.
The brains, dementia brains have a compromised ability to use glucose. And we know this in human studies looking at glucose tracking to the brain, radio imaging. And sure enough, if the brain can't use glucose, there's only one other fuel. That's the ketone. But anyway, our fear of ketones means people don't want them at all. But back to my story, I would see...
That's pretty much the last point I wanted you to make is like even on autopsy, postmortem, even on autopsy, the difference was you had unimpaired ability per gene expression, which means, the genes are still viable to use ketones, unimpaired. Whereas those who had impaired dementia was the category he used. They were very impaired. The ability to use glucose was very impaired. And that's amazing. That's a big, big deal. So I hope you got that as a take-home message, that the ability for our brains to use ketones has always been there since birth. I left that part off. I thought that'd be way too long of a whatever kind of podcast we're doing today. And that it's something you really, the information there is now undeniable. So how you choose to get there is entirely up to you. And I mean, that's certainly what I am about. I'm about broadcasting this and making sure that everybody is aware of this, that wants to be aware of it. And that is just so much interesting information that is coming out in the last couple of years, the last 5 years, maybe the last 10 years, that makes us look twice at this diet, quote unquote diet, that has been around really forever. So with that, I am going to close because we have to put all these pieces together and make a podcast. I hope you enjoyed it. I hope you got something out of it. And what I'm going to do is link in the podcast that you got pieces of. And until next time, this is Dr. Carl Goldkamp. Hi, this is Dr. Goldkamp. I just wanted to encourage you to send in your questions to drgoldkamp@ketonaturopath.com. Many of you have, and so what I've done with these questions that gotten back to most of the people I email, but some of the questions that were so good, and if they were overlapping to other questions, I would combine them and try to put that into the topic of a podcast, either via one of the micro topics that are covered in an interview. As you know, we cover a lot of topics in any given interview, or some of my own sort of reporting, if you will, on some of these issues. So please keep the questions coming. Feel free to send in an email, and I will get back to you. One thing I want to say, a number of questions have come in which I've given this answer and the email didn't work. So just make sure that you're receiving at the same email that you sent it in. And I think that might have been the difficulty. So I look forward to your questions. I just wanted to make sure that you knew that I'm open to answer your questions. And I think this world of keto is not just black and white. It's nice that it's simple, but it's not simple for some. I'm really trying to, go down as any of you who have listened to all my podcasts. We started way back when, history and evolution and epilepsy and so on and so forth. Now we're seeing some tremendous overlap in various mental disorders, such as schizophrenia or neurological disorders that are not just epilepsy. And also, just for people in losing weight, it's sometimes pretty complicated for them to engage in keto, and so they need some help. And so that's the whole point of, at least that's what I think I'm doing, is exploring the world of why are there other factors. And so in exploring some of those other factors, we've covered addiction, we've covered hormones, we've covered nutritional deficiencies, we've covered certain metabolic lab results, and we'll go further. We'll even get to more on genome and aspects. So these are all just contributions that make for an obstacle for some people to engage easily in the ketogenic diet. This is my belief, and these are the things that I've discovered. And I think other people have discovered some of these things, but not ever put them together. So stay listening, send in your questions, and I will definitely get back to you. Bye-bye.